Good morning, this is Unit 2. This is learning target 2B. We're going to start off with domain and range. And we're going to go back to middle school for a little bit and talk about domain and range, how we learned it in middle school, and we'll build it up to Algebra 2. So first, find the domain. I take a little bit to remember. These are all of the x values in your graph. So we look at each. In this case, there are coordinates, points. We'll look and find all the x values. So it might be helpful just to actually find the coordinates of each point. We have 1, 5. It's like 3, 5. 4, 2. And 6, 2. Well, if we're looking for the domain, we're going to look for all the x values. X values come first. Is x and y. So looking at all our x values, put them in order from least to greatest. Don't also have to be left to right. Put them in bracket 1, 3, 4, 6. And as our domain, this is what you did in middle school. Range, look at all the y values. So we have 5. Another 5, 2, -2. So our range, again from least to greatest, and this time is bottom to top. -2, 2, and we actually do not write 5 twice, we write it just once. Alright, moving on to Algebra 1. So here we have a line segment. And a line segment, there's an infinite amount of points within a line segment. So we really cannot just state every single coordinate point. Anywhere along the line, a line is made up of an infinite amount of points. So anywhere along here, there are coordinates. And every time I draw a little point, there are an infinite amount of points within, in between each point. So there's no possible way to actually say every single x value by writing them all out. But we can write them by saying what's the lowest x value over a coordinate or graph, and what's our highest. So what we do from left to right, I always put these graphs left to right. First coordinate here is, so the farthest left coordinate is at 0 for the x, and we're talking domain, so that's all I'm going to write right now is 0. Farthest right coordinate on our graph is at 4. If I can draw a straight line, it actually would go down to 4. It's close. So we are going to write a compound inequality to describe this. So there is an actual point at 0 here for the x. We're going to write 0 less than, since we have an actual point there, a coordinate, it's going to be equal to, the domain is always the x values. And then we look at the farthest right value here, biggest x value, that's at 4. And there's an actual coordinate there, so again it's equal to then 4. So it's the same. Our domain, our graph is between points 0 and including 0 and 4, also including 4. Range-wise, let's look at the range. Range is the lowest y value, so let's look at the lowest point on the graph, and that's at -1, to the highest point on the graph, which is at 8. Alright, so the lowest point is at -1, and there's an actual coordinate there at -1. So we get -1 less than, since there's a point there, a coordinate, -1 is less than or equal to because there's a point there. The range is always your y values. That's less than, and there's a point at the y value of 8. So it's again equal to 8. So this is telling us our range between -1 and 8 in our whole graph. Moving on to today. Just a couple quick definitions. This is for 2B. We're talking about domain, range, zeros, intercepts. Intercepts are x and y intercepts. The domain, we'll just say all x values of the graph. The range Zeros, you might have remembered these from Algebra 1. Zeros, just x-intercepts. So it's where the graph crosses the x-axis. And intercepts, there are two different types. There are x-intercepts, which I just mentioned. Is where the graph crosses the x-axis. And there are y-intercepts, where does your graph cross the y-axis. Let's do a couple examples. So we need to find the following. We need to find the domain, range, zeros, and intercepts of each graph. So domain. Now this is moving on from Algebra 1. These graphs are continuous. They are not just line segments. They continue on. If you look here in the top left, continue on forever and ever, and down forever and ever. So they continue in that path forever and ever and ever. So domain-wise, I mentioned those, how far left and how far right can you go? Well, if I'm going, I start always, it's like reading a book. Graphs, books, same thing, left to right. Even though this graph is going this way, and I'm drawing in, the arrow's going up, remember that you have to imagine that it's going up and to the left forever. So when you're reading this graph, you read it left to right. So coming in from the left, it's coming from, the x values are coming from negative infinity. And then less than can't be equal to negative infinity. Infinity is just an imaginary thing, it's not real. The domain is always x. How far right will the graph go? So the graph continuously goes down, but I don't really care what down with domain. Domain is left and right. So how far right will it go? Well, it will continue on forever and ever to the right to infinity. So in this case, the domain is negative infinity to infinity. Now the range, how low to how high the graph will go. Remember that this continually goes, left side goes up, right side goes down. Range is how low to how high will the graph go. It's the lowest points to the highest points. So the graph continually is coming from, it'll continuously go down. So we're reading this graph bottom to top. Yeah, it's coming from negative infinity. The range is y values. That's going to go to infinity. Infinity. Keep on going up, up, up here. Zeros. Look at your points that cross the x-axis. There are 2 points here. This point here is at 2. Put 2, 0. And there is another point here. This is a special point. It's called a double zero. So there's another 0 is at 0, 0, that's a coordinate. It's nothing to do with that, it's at 0, 0. The double zero is the fact that the graph turns right on the x-axis. This is called a double zero. So then we actually will write that twice. Intercepts. X-intercepts, those are just the same as zeros. 2, 0, 0, 0. Another 0, 0. And then the y-intercept just so happens, in this case, be the same as the x-intercept. That's just at 0, 0. Or you could just say 0. Okay, we're just going to do one more example. This is example 2. So looking at our domain here, domain is how far left and how far right will the graph go. So here we have, it's going up to the left, up to the right. Imagine that these are going on forever and ever in those directions. So domain is how far left will this graph go? Well, it looks like as it's going up, it's going to go to the left. So when I'm reading this graph, I'm reading it from the left. You have to imagine that it's coming from negative infinity on the x values. And it'll continuously go to the right, infinity. The range is a little different from our last example. The lowest point on the range here, on this graph, is at negative 1. So it's a different color. Negative 1 is our lowest range y value. There's an actual coordinate there, so it's going to be less than or equal to. And highest point? Well, both sides continue on up forever and ever. So I go to infinity. Zeros. Just like two zeros here. I have -3 and -5. So -3, 0, and -5, 0. Intercepts, the x-intercepts are just the same. -3 and -5. The y-intercept, let's estimate. Go up, cross somewhere around there. Looks like that's 9, 10, 11. We'll say that's at 12. So y-intercept is at 0, 12. Come to class with some questions. Thank you.